In this question, we're talking about a high school cross-country team that's going to Chicago to watch the marathon. And we're given 2 points that are on a map that was superimposed onto a coordinate plane. The high school is at point 24, and the start line of the marathon is at 6:09. Our mission here is to try to figure out the approximate distance between the high school and the marathon. So what we have to do is distance formula, and then we're going to have to do one extra step at the end of the problem, which has to do with the scale that we are given. So the first thing I'm going to do is the distance formula, which I'm going to write up here at the top. This formula will need to be memorized when you're taking the test. So I'm going to list out my 2 points, 2, 4, and 6, 9. I'm going to label my points x1, y1, x2, y2. And now I'm going to plug everything into the distance formula. And what I like to do is set up my formula without numbers. And now I'm just going to plug them in. So x2 is 6, x1 is 2, and then y2 minus y1 would be 9 minus 4. At this point, what I like to do is put everything that's under the radical into my calculator. So I put everything that's written here in green except for the square root. And what you'll get is, let's see, 16 plus 25, so that would be 41. So I get the square root of 41, but that's not my final answer, because now I need to take that square root of 41 and I need to multiply it by the scale that we were given, which is right here. So this number here, the square root of 41, tells me how many boxes on the grid it is away, but I need to know, since each of those boxes is 9.5 miles, how many miles are we talking? So now I take this square root of 41 and I multiply it times 9.5, and I end up getting 60 point something, which I'm going to round to the whole number, 61. And my final answer is in miles, so that's it. This problem goes with the information you were given in problem 1. Now we're talking about a rest stop that's halfway between Joliet Central in Joliet and Chicago. So what I want to know is, what are the coordinates of the rest stop? So when you see the word halfway, that's an indication that we are going to be using midpoint. So I want to write the midpoint formula up at the top. This is another one you're going to have memorized. Okay, and then just because it's not actually typed out here, I want to write down the 2 points. And those points are 2, 4, and 6, 9. All right, so I'm going to do my labels again, just like I did on the previous slide, x1, y1, x2, y2, and now I'm going to take those and actually plug them into the midpoint formula up at the top. So x1 and plus x2 would be 2 plus 6 over 2, and then my y's would be 4 plus 9 over 2. 2 plus 6 is 8. 4 plus 9 is 13. So my final answer, 8 divided by 2 gives you 4. And then 13 divided by 2, you could leave it as a fraction, or you could write it as a decimal, which is 6.5. We need to write the equation of a line that is parallel to this given line here and contains the point 37. So the very first thing we're going to do is take a look at the equation that we're given, and we need to identify the slope of that line. So in order to do that, I need to solve it for y. So I'm going to be subtracting 8x from both sides. So those cancel, and I have 3y equals negative 8x plus 12. Now I have to divide everything by 3. So I end up with y equals negative 8 over 3x plus 4, because 12 divided by 3 is 4. So now I can tell you that the slope of this line is negative 8 over 3. Okay, next thing we need to identify is whether the problem asked us to find a parallel or perpendicular line. So if I read the question again, I see the word parallel here. So I want a parallel slope. parallel slopes are the same, so that means the slope I want to use is also -8/3. The last piece of information that we need is this point here. This is what I'm going to plug in for x and y into my slope-intercept form. So now I'm going to rewrite, here's slope-intercept form, and what I'm going to do is plug in my m and my x and y into this y equals mx plus b, and I'm going to solve it for b. That's going to give me the y-intercept of the line of my answer. And then I'm going to plug my information back in for my final answer. So the first thing we need is y. My y value is 7. And then I have equals. My m value is -8/3. X is 3. And then I have plus b, which is what I'm solving for. Okay, if you simplify this, -8/3 times 3 comes out to just be -8. And then to solve for b, I would add 8 to both sides. So I get that b is 15. So now my final answer, y equals my slope, 8/3, x, plus the b value that I just found, which is 15. We're going to be using this information for the next 3 questions. It's telling us that we have a quadrilateral ABCD. The side lengths and slopes of each side are given below. And we want to find out what's the best name for quadrilateral ABCD. So the first thing I like to look at are the lengths. I see that I have opposite sides that are congruent. So I know that now I'm narrowed down to 2 choices. So let me write this down. I have 2 pairs, opposite sides that are equal or congruent, either way you want to use that word. So I have 2 choices. My first choice is that it could be a parallelogram. The second choice is that it could be a rectangle. The difference between a parallelogram and a rectangle is that a rectangle, when you look at the slopes, will have perpendicular slopes because each corner of a rectangle is a right angle. So those lines need to be perpendicular to each other. So what I'd be looking for is if they have opposite reciprocals. In a parallelogram, the angles on the corners are not right angles. So I'm looking for slopes that are not opposite reciprocals. So now let's take a look at the slopes here. I have 2/3 and -3/2. Those slopes are opposite reciprocals. If you flip 2/3, it gives you 3/2, and I have 1 positive and 1 negative. So these are opposite reciprocals. What that means is that my final answer is that this is a rectangle. Here's the same information, so that same chart that we were just looking at, and now we're trying to find the perimeter. So remember, we know this is a rectangle, so it might be helpful to draw a picture. So I'm going to write A, B, C, and D. I know that side AB and side CD are the square root of 5, and then the other 2 sides are 3 square root 5. So to find the perimeter, what I need to do is add up all 4 sides. So I'm going to add up 3 square root 5 plus square root 5 plus 3 square root 5 plus square root 5. Now remember, when you're adding radicals, as long as they have the same radical, you can add the numbers in front. So even though you can't see it, there's really a 1 in front of the square root of 5. So that's how many we'd be adding. So what I'm really going to do here is add 3 plus 1 plus 3 plus 1, which comes out to be 8. And then the square root of 5 tags along with your answer. Now we're finding the area of the same quadrilateral. So I'm going to draw the picture again. So from question 4, I knew that this was a rectangle. So I'm going to label my sides again. Square root of 5 for the short sides, and then 3 square root 5 for the long sides. So to find the area of a rectangle, it's length times width. So basically you just need to multiply one of each length together. So I'll say that the square root of 5 is length, and then 3 square root 5 is my width. So I'm going to multiply the square root of 5 times 3 square root 5. You can put this into your calculator. It will give you the answer. But essentially all that's happening is I'm multiplying the numbers that are in the same places together. So I can multiply square root 5 times square root 5 because they're both under a radical. And if you remember, if I take a square root and multiply it by itself, it's really like I'm taking that radical and squaring it, and the answer just comes out to be the number underneath. So essentially what I have here is the 3 that was on the outside, and then when I multiply the two radicals together, it turns into a 5, and 3 times 5 gives us 15. I want to know if the line through points A and B is perpendicular to the line through C and D. And then it asks us to explain. And a lot of our explanation is going to be shown with our work. So whenever you're asked to determine if anything is parallel, perpendicular, or neither, what we want to use is the slope formula. So I'm going to write the slope formula up here. This is another formula you'll have to have memorized for the test. So I have to do two slope formulas, and then at the end we're going to look at our slopes and decide if they are the same. So that would mean that they're parallel. If they're opposite reciprocals, that means that they're perpendicular lines. And if it's anything else, that means they're neither. Okay, so let's do A and B first. So A is the point 0.07. B is the point 0.39. We can label our points x1, y1, x2, y2. And then to actually calculate the slope, I would have y2 minus y1 over x2 minus x1. So I get 9 minus 7 is 2, and 3 minus 0 is 3. So that's my first slope. Now I'm going to do the same thing with points C and D. So I'm going to label again x1, y1, x2, y2. And now for my slope, I would have negative 2 minus 1 over 0 minus negative 2. Negative 2 minus 1 is negative 3. 0 minus negative 2 actually turns into 0 plus 2, which is 2. So then my slope is negative 3 over 2. So what I'm checking to see is, are they the same? The answer is no, they're not the same. So they're not parallel. Are they opposite reciprocals? So if I took 2/3 and I flipped it upside down, it would give me 3 over 2. And then I have to check. The purple one is positive and the green one is negative. So yes, they are opposite reciprocals. So that means that these two lines are perpendicular. So over here, I'm going to write yes, they are perpendicular because their slopes are opposite reciprocals. Question 8 is asking us to find out which two lines are parallel. So essentially all we have to do here is solve each of them for y and determine what the slope is. And since we're looking for parallel lines, I'm looking for two lines that have the same slope. So for number 1, I have 2y equals negative 3x minus 4. To get y by itself, so that it's in slope-intercept form, I need to divide all of my terms by 2. So I end up with y equals negative 3 over 2x minus 2, since 4 divided by 2 is 2. And then all I'm looking at is the number next to x. So my answer for number 1, my slope is negative 3 over 2. Now I need to do the same thing for number 2. I have 2y equals 3 plus 6x. This one looks a little funny because usually the x term is first. It actually doesn't matter as long as you know that when you're looking for your slope, it's the number in front of x. So I'm going to do the same thing and divide by 2. So I end up with y equals 3 over 2 plus 6 divided by 2 is just 3. So I'm going to write plus 3x. Now again, I'm looking at the number next to x, so I have a 3. And then last but not least, number 3, I have 2y minus 6x equals negative 4. This one's going to be the most work because I have to move my x term before I can divide. So I'm going to add 6x to both sides. And I end up with 2y equals 6x minus 4. And now I'm going to go and divide everything by 2. So my final equation would be 3x minus 2. So again, I'm looking at the number in front of x. So the slope is 3. So now since I'm looking to see which ones are parallel, I'm picking the ones that are the same. So that would be lines 2 and 3. So my final answer is 2 and 3. For this problem, we're given the equation of a line that's talking about a support beam on the Jefferson Street Bridge, and we're trying to figure out the equation of a perpendicular brace that is perpendicular to the support beam and is passing through the point -8,3. So this is essentially the same problem as problem 3. It's actually a little bit easier though because we don't have to solve for y, it's already in slope-intercept form. So here's my equation, y equals 2x minus 5, and what I want to do here is figure out the slope. So I'm looking for the number next to x, which is 2. So the slope of the line that we're given is 2. However, when you look at the problem, it's asking us for a perpendicular line. So I'm not going to use the slope of 2, that's what I would use if it was parallel. So the perpendicular slope would be the opposite reciprocal of 2. If it helps, you can write this as 2 over 1, and that way you can see it as a fraction. The reciprocal would be 1 over 2, and then since my blue slope is positive, my opposite reciprocal would need to be negative. Now I have a point here, -8,3. That's going to be the x and the y that I plug into slope-intercept form. So over here, here's slope-intercept form. And what I'm going to do is take x and y and my new perpendicular slope and plug this in to solve for b. So my point for y is 3. And that equals slope, which is -1/2, times my x value, which is -8. And then I have plus b, and b is what I'm trying to solve for. So now I need to simplify -1/2 times -8. That comes out to be 4. And it's positive 4 since it's a negative times a negative. And now I'm going to be subtracting 4 from both sides. So I get that b is equal to -1. So now I need to take the two pieces of information that I have here, so my perpendicular slope and now the b value that I just got, and plug it back into slope-intercept form. So now I would have y equals -1/2 x minus 1 for my final answer. Number 10 is asking us to graph the following 4 points, and then we need to find the length and slope of each side. So this one's going to be quite a bit of work. So let's get started with our points. I need to plot -5,8. And I'm going to label that as A. B is 3, 4. C is 5, -7. And D is -3, -3. So I'm going to connect all the dots, and I want to make sure that I connect them in a way that makes this into a quadrilateral. So be very careful to make sure that when you're doing these types of problems, you want to graph the points to make sure that the letters are connecting in the way that you think they are. So now we have to do 4 distances and 4 slopes. So I'm going to write the distance formula up at the top. And again, this is something you're going to have memorized. Okay, so for number 10 here, let's see, we have to do 4 sets, sorry. So we're going to do the distance of AB, the distance of BC, CD, and DA. So all 4 of these distances. So for the AB, I'm going to plug in my points. So I would have 3 minus -5 and 4 minus 8. And when you put this all into your calculator, you should get the square root of 80. For BC, you would have 5 minus 3 and negative 7 minus 4 for a grand total of the square root of 125. Now you'll notice I'm not doing factor trees with these because what this is leading into is question 11, where it's going to ask us to classify. So I'm not so concerned about what the final distances are. I'm more concerned about, are they the same? And I can tell that without having to do a factor tree. For CD, I'm going to have negative 3 minus 5 and negative 3 minus negative 7 for a grand total of the square root of 80. And last but not least, we have DA. So my points, or my numbers, would be negative 3 minus negative 5 and negative 3 minus 8. And you end up with the square root of 125 again. Now I have to do 4 slopes. So I have to do the slopes of the same 4 segments. Okay, so I'm going to write the slope formula up at the top also. Again, something you have to have memorized. Okay, so now we're going to plug these things in, and kind of a shortcut, and it only works if you're really confident that you did the distance formula correct. This y2 minus y1 right here is the same y2 minus y1 that's in your second set of parentheses. And then the x2 minus x1 is the same as this x2 minus x1. So you can just basically transfer those into your fractions. Just be very careful that you're putting everything in the right spot. So for AB, I would have 4 minus 8 over 3 minus negative 5. 4 minus 8 is negative 4. 3 minus negative 5 is 8. And if you reduce, you get negative 1/2. For BC, we would have negative 7 minus 4 over 5 minus 3. Negative 7 minus 4 is negative 11, and 5 minus 3 is 2, and there's nothing else I can do to simplify there. CD, I would have negative 3 minus negative 7 over negative 3 minus 5. Negative 3 minus negative 7 actually comes out to be positive 4, and then that would be negative 8 for the denominator, which reduces to negative 1/2. And last but not least, for DA, I would have negative 3 minus 8 over negative 3 minus negative 5. So this turns into negative 11 over positive 2. So those are my 4 distances and my 4 slopes, and that's all this problem is asking so far. This is talking about the values we just found in problem 10. It's asking us to classify the quadrilateral. So what I want to do before I actually show you this is write down all of the answers. So we had 4 lines, or 4 segments. We had AB, BC, CD, and DA, and we had to find both distances and slopes. So I'm going to write the distances first. So they were the square root of 80, the square root of 125, 80, 125. And then we also had to calculate slopes. They were negative 1/2, negative 11 over 2, negative 1/2, negative 11 over 2. All right, so part A asks us to classify. So first thing we need to do is look at the sides. I notice that I have 2 pairs of sides that are equal in length. So it might not be a bad idea to draw a picture, just kind of a generic quadrilateral. So I'm going to label A, B, C, D. And then my distances are the square root of 80 on the sides and the square root of 125 on the top and bottom. So I can see that those pairs of congruent sides are opposite from each other. So this tells me that I have 2 choices. It's either going to be a rectangle or a parallelogram. So those are my 2 choices based on the distances. The difference between a rectangle and the parallelogram are the slopes. If I look at the slopes and they're opposite reciprocals, that means that I have right angles. That would mean it's a rectangle. If I look at my slopes though, you'll see that I have -1/2 and -11/2 as my two different slopes. Not only are they not reciprocals, they're also not opposites. So these are definitely not perpendicular lines, which means that my answer is a parallelogram. And then for part B, to explain my choice, I would just basically concisely write what I just said. So I would say that there are two pairs of opposite equal sides. And it's important that you say opposite because if they were adjacent equal sides, that would make it a kite. And the slopes of the lines are not perpendicular. Parallelogram ABCD gives us these coordinates, and it's actually already graphed for us, which is wonderful. And then it's asking us to verify that it is a rhombus by showing that it has perpendicular diagonals. So what we're going to have to do is we're going to have to do two calculations here. Since we're trying to determine if the diagonals are perpendicular, that tells me that I need to calculate two slopes. The next thing that's really important is to make sure that you are using the right letters as your diagonals. So make sure you're connecting the opposite vertices. So one of them is going to be AC, which is points 0, 3, and 3, 0. And then the other one is going to be diagonal BD. And B and D are points 5, 5, and -2, -2. All right, so we're going to use the slope formula, which I'll write at the top. y2 minus y1 over x2 minus x1. So for AC, I'll label my points too. x1, y1, x2, y2. I would have 0 minus 3 over 3 minus 0. So that's -3 over 3, which simplifies to -1. And then for BD, I'm going to use the same formula. And I would have -2 minus 5 over -2 minus 5. So -7 over -7 or +1. And these two slopes are opposite reciprocals of each other. So I just verified that they are perpendicular slopes. So this is a rhombus. We're given 3 points, A, B, and C, and then we have a list of 4 things that we need to do. Part A asks us to find the length of each side of the triangle. So what I'm going to do first, there's a blank graph down here at the bottom. I'm going to plot my points because it helps me just to make sure that everything is working out the way that it's supposed to. So I'm going to plot A, which is at 0, 4. B is at 4, 5. And C is at 1, 0. So here's my triangle. And now let's work on part A, which is to find the length of each side. So my 3 sides are AB, BC, and CD. I'm sorry, CA. Okay, so now we have to do the distance formula 3 times. And I'm going to write the distance formula right underneath the question for part A, just so that it's here. Okay, so for AB, I have to use points A and B. All right, so I would plug in, let's see, 4 minus 0 and 5 minus 4. And this comes out to be the square root of 17. If you put that in your calculator, you'll get 17 under the radical. It doesn't simplify, so we're just going to leave it how it is. For side BC, I have 1 minus 4 for my x2 minus x1, and then 0 minus 5. This comes out to be the square root of 34 after you simplify. And then my last side, CA, I would have 1 minus 0 for my first set of parentheses and 0 minus 4 for the second set of parentheses. And that comes out to be the square root of 17 also. So I'm going to go on my picture here and I'm going to label my 3 sides. So that was the square root of 17, BC is the square root of 34, and then AB was the square root of 17. All right, so we're done with part A. Part B asks us to classify the triangle by angles and side length. So based on my work from part A, I can already tell that this is an isosceles triangle because it has two equal sides. So I know that that part is done, but I do need to check on the angles. And in order to do that, we're going to use the converse of the Pythagorean theorem. So what I'm going to do is add a squared and b squared, and I'm going to see how it relates to c squared. So is it equal to, greater than, or less than? So the first thing we need to do is go back to part A. I'm going to put a star next to BC because that is my biggest side. That means that when I plug this in, I'm going to plug in BC for the C value. So I have the square root of 34 as my C value, so squared, question mark. And then a squared and b squared are actually the same number, so it kind of doesn't matter which one is which. Okay, now the nice thing is that the squares and the square roots cancel each other out, so I end up with 34 and then 17 plus 17, and if you add 17 plus 17, you actually get 34. So what that means is that since the two sides are equal, that means this is a right triangle. So it's a right triangle, and we decided from our answers in part A that it's isosceles because it has two equal sides. Part C asks us to determine the perimeter. So I'm going to take my three sides, which are the square root of 17, the square root of 34, and the square root of 17, and I'm going to add all three. I'm going to add the two that are like radicals, and what I'm really doing is adding the number in front, which I'm going to write in there as like an invisible 1. So I have two square root of 17s, and then I just have the square root of 34 by itself, so it just kind of gets added along, and that's my perimeter. Last, I'm asked to determine the area of the figure. The area of the figure, since it's a triangle, the formula is 1/2 base times height. Since this is a right triangle, and by the way, my right angle would be across from the largest side, so that's how I know the right angle is at A. When you're looking at a right triangle, the base and the height for your formula will be the two legs, so the two smallest sides. So that means that my base, and it doesn't matter which is which, I'll make the base AC, and then I'll make the height AB. Oops, I wrote B instead of H. Okay, so now I just have to plug everything in. So this is 1/2, the base is the square root of 17, and the height is also the square root of 17. If I multiply the square root of 17 times itself, I get just 17, because it's really like I have the square root of 17 squared. So my answer is just the number 17. So what I really have here is 1/2 of 17, and if you divide 17 by 2, you can leave it like this, that would be fine, or you could write that it's 8.5. So two answers that would be acceptable would be 17 over 2 or 8.5. All right, so we are looking at a graph here of Mrs. McNally's classroom, and there are 3 bathrooms located, and since she really has to go to the bathroom, she has to find which one of these bathrooms is closest to her, so she can decide which one she can get to the fastest. So I'm going to do the distance formula 3 times. The first thing that I want to do before I do any distance formula is I want to identify my 3 ordered pairs. So McNally is at 3, -2. Bathroom A looks like -4, 5. Bathroom B is at -5, -5. And bathroom C is at the 0.71. So now I have to do all these distances. And I'm going to write the distance formula at the top here. So x2 minus x1 squared plus y2 minus y1 squared. All right, so let's figure out, let's do bathroom A first. We'll just go in alphabetical order. So bathroom A. So I have to make sure that I'm using the right points, and I'll actually write down the 2 points that I'm going to use here. Every one of these distance formulas will use point McNally, and then I have to use point A, or bathroom A, which is -4, 5. So those are going to be the points I'm going to plug into this distance formula. So I would have -4 minus 3 and 5 minus -2. And when you plug all of that in, you end up getting the square root of 98. Now, normally I would say you should break this down and figure out what the simplified radical form is, but it specifically tells you in the question that it wants you to round to the nearest tenth. Tenth is talking about 1 decimal place, or 1 number after the decimal. So if you put this into your calculator, you will get that this is approximately 9.9. So that is our distance for bathroom A. Now I have to repeat this for bathroom B. So I'm going to write down my points. Again, we have to use 3, -2, and then the point from bathroom B is -5, -5. Okay, so I would have -5 minus 3 and -5 minus -2. The number under the radical turns out to be 73. And when you put that into your calculator, you'll get that it's approximately 8.5. And again, I'm rounding to 1 decimal place. Now we have to do bathroom C. I have to use the McNally point, and then bathroom C's point is 7.4. I think I wrote down the wrong point here. So this should be 7.4, not 7.1. Okay, so now I have to set up the formula. And my points would be 7 minus 3 and 4 minus -2. The number under the radical turns out to be 52. And when you put that all into your calculator, you would get 7.2 as your answer rounded to 1 decimal place. So now when I take a look at all 3 of my answers, I'm looking for the shortest distance, which means the smallest number. So if you look here, 7.2 is your smallest value. So that means that I should go to bathroom C. That's the closest. So I'm going to write here, bathroom C is the closest to Mrs. McNally's classroom.